Hello and welcome to a new episode of the BIMvoice podcast. Today, our guest is Magnus Rømoen from the Norwegian Geotechnical Institute. Welcome, Magnus.
Thank you. Thank you very much.
It's so nice to have you here. Let's start by presenting yourself a little bit.
Yeah. As you said, my name is Magnus Rømoen. I'm working at NGI, or Norwegian Geotechnical Institute. My background, my education from NTNU, Masters in Geotechnics, and then I've been working here at NGI for 14 years. The first 6 years I worked with projects, all sorts of manners, and then the next 8 years I was a section leader at the onshore foundation section. And then for the last 2 months, I've been responsible for the BIM development at NGI. So my title is BIM strategist. Yeah.
I see. So this is not an old job. This is a new position created for the Norwegian Geotechnical Institute. Am I right?
Yeah, we have quite a large transformation when it comes to BIM from the last year approximately. And as a result of this transformation and development, we saw that we also need a position which is bound up to the BIM development, the further BIM development. So my position is part-time BIM development, and then also part-time working on projects. So as I heard that you had Øyvind Svarland here last week. He's the BIM responsible for the BIM at the UDK project in Drammen, and I'm NGI are working with the same project, and I'm the project leader for that project in Drammen.
Okay, interesting. So you work on the projects as well, I see.
Yeah.
But it's anyway, it's really nice that institutions realize that they need people to do exactly this job, to plan for how to implement BIM and how to approach it on the project. And I'm sure right now maybe this is a transition phase where you are just discovering how you should do it, how you approaching. But I'm sure in the future you are going to get more drawn into this, working more on the strategy and less on the project. It's something that
That's
with time.
something that we just have to see that will develop. I think that's our development on that position is a little bit like the digital development. You have a direction, and then you have to see what happens on the way. And you don't have like a final goal. This is where we're going to be in 5 years, but it's a direction. So we'll see what happens.
Yeah.
But I might also say that's okay. About NGI, it sounds pretty governmental, but we're not governmental. It's a private research foundation. So we're not the part of the government. We're not like the governmental organization like Statens vegvesen and Bane NOR. We are a private research foundation, which also makes that we work with a combination of consultancy and research, and that's also the important for us that the daily work is partly research and partly consultancy.
I understand. It's really nice. You just read my mind, because this was exactly what I wanted to ask you right now.
Okay.
But it's a big company. How many employees are you?
We are approximately 300 employees.
Wow. Okay, so big it is.
Yeah. So, but we work in different market areas. So I'm part of the geotechnics and environmental market area, which is mainly working on onshore projects. We also have an offshore market area. We have natural hazards market area, and we have a market area called geodata and technology, which is mainly based on field investigation, lab work, and instrumentation and monitoring. And NGI has our main office is here in Oslo. I'm sitting in Oslo now, where the majority of the people are sitting. We also have an office in Trondheim, here in Norway. And then we have daughter companies in both the US and in Australia. So we have 2 offices there as well.
Oh, interesting.
But they are then mainly offshore related, those offices. And I think they're like somewhere between 20 and 30 persons in both of those locations.
I see.
Yeah.
Yeah, that sounds good. Let's get back to our main topic here a little bit, and please tell me with your own words, what is BIM for you?
I think if you talk like BIM is the future or the way we want to communicate our design to our clients. We want to give them complete models, which has all the information that we want to communicate to them. That means we don't only want to give them a 3D model, but we want to give them information about what kind of materials you're talking about, how you're going to execute the construction phase, and so on. Of course, for geotechnical engineers, the BIM part is a little bit divided between both making structures, but also giving 3D models of the soil conditions or the bedrock conditions to the clients. So that's also an important part of the BIM, is to have a 3D model of the lithography of the subsurface and say to the clients what to expect when you're doing the construction work.
I see. Interesting. I don't know personally too much about how BIM is perceived and used in geotechnics, geosciences. So this is really interesting and exciting to find out more about it.
I think the subsurface part of BIM has been lacking behind a little bit, being left behind a little bit. Like my impression is BIM in general has come pretty far when it comes to buildings. It's maybe struggling a little bit more when it comes to infrastructures, roads and railroads. You haven't maybe come that far. But anyhow, when it comes to buildings as well, everything that happens beneath the soil, that's not very much handled in the projects. So I think that's something that we really have to make better in the future to improve.
Yes, sure. I think generally, like maybe geosciences are not the sexiest parts of the buildings, right? So that's why people tend to not think too much about that. But let's not forget how important that part is, because everything we build upon that might just disappear if we don't do a good job there under the ground, right?
I think it was one of the founding fathers of the geotechnics who said it's not much glory in foundation, and that's really true, because normally you don't see what we do. Expect when everything goes wrong, then we got to blame afterwards. So the geotechnical part of a project, that's something that everybody just expect to work, and then if it doesn't work, then you have problems afterwards, and it costs a lot of money. So yeah.
Yeah. So only when when a pain appears. Yeah. That's not the best, but like here the syndrome of shiny objects. It's like the same with the operations and facility management part of the projects, right? We don't focus too much on that. When we focus always to build it, right? To build it as soon as possible. So yeah, we don't treat that with the same interest as the self building or other details or technical systems or something. But nonetheless, like I said, it's likewise like every other discipline. It's critical. Like you cannot do anything ignoring a discipline, right? So each discipline it's very important for the entire to make good buildings that will last for many years.
I think some of the challenge we might have, as I said, it's stuff that you don't see afterwards, but it's also what is important for us when it comes to 3D and BIM models of the soil conditions is also communicating around uncertainties. I think Øystein Ulvestad, some weeks ago, we talked about how to communicate in the model that this rebar has to have this precision or a larger precision. So some rebars really have to be on the correct millimeter, but while other can be moved centimeters, and that's how to communicate that. Our challenge might be that, okay, we make a 3D model based on 2D points or 1D point information.
Yeah.
Which means we have a drilling going down on some of the locations, and then we're doing interpretation between these points. And of course, if the distance between all those points are 5 meters, the detail level is much higher than if it's 100 meters.
Exactly.
What you end up when you have a large 3D model is then how to manage to communicate these differences, that, okay, in this area, we are pretty sure about the soil conditions, but in these other areas we are not so sure because the distance between the information points are higher, and that's something that we have had some focus on to manage to communicate that to the client, that okay, this is what we expect and this is what we know, and this is what we're really guessing on. So yeah.
Yes, exactly. It's a very much a very like a guessing game for like in between the points, and like this depends also on the importance of the place, right? If you it's a very important place closer to the building or the structure, or yeah, you can make more holes, right? But another thing aspect actually that I forgot to mention in the start is like it's also expensive. Geotechnical works are very expensive, and that's why you need to employ this you don't have the precision, like you don't know anything, you cannot just make a hole each half meter, right, to find out the exact. So that's why you just need to use models and to model, right?
Yeah, and of course, and that's the density of the site investigation, which we're kind of talking about now. They must depend on what you're actually building. If you're having a road directly on a flat terrain, okay, maybe then you need to have a rather large distance between the site investigation. But if you're having a bedrock surface which varies a lot, and you're going to have a sheet pile wall rammed down to the bedrock surface, then you really have to have a short distance between all the drilling, so you're sure about, okay, how is the surface variating of this distance that you're actually establishing the sheet pile wall.
Yes, because the risk is much higher of future accidents. But if we talk, we have this challenge, right? It's difficult to find out what we have behind. How is the technology? How is evolving the technology, like laser scanning or all this? There must be some technology that are improving every day, right? From this aspect to get more precision from scanning.
When it comes to what's happened subsurface, you have some methods which is really still evolving. NGI has a spin-off company which is working with airborne electromagnetics, for example, which gives you a large 3D model of the subsurface conditions and the variation in resistivity in the different soil layers and so on. So what we do there is we combine these large AEM models with site investigations, so that you have these 1D really sure information, and you tell the model, okay, here I'm really sure about these conditions, and then you try to interpolate them within the model based on how the resistivity is shown in the rest. That's really some nice work that we have been working with for the last, 6, 8, 10 years or something, and which we are still now developing. But like when it comes to Norwegian soil conditions, like in the Oslo area, and it's a lot of clay, which is the main, if I can call it, challenge. But for us, it's the main fun, kind of. Finding the conditions on the clay, we're very reliant on using traditional site investigation, taking samples, taking drillings to really find good information on the soil conditions.
I understand. Did you mention before AI? Did you say AI at some point, or did you mean artificial intelligence?
No, I said AEM, which is airborne electromagnetics. So I didn't mention.
No, then I misunderstood. But regarding AI and machine learning? What do you know? Do you know any applicability for this?
Machine learning is something that we're doing at NGI. We're doing quite a lot, and been doing for the last years. And this is very often based on bound to interpretation of the soil conditions. You have one kind of method, what to expect based on other information. So taking a sample is very time consuming and costs a lot of money. Just doing a drilling down, registering the in situ conditions, that's cheaper. So if we can, based on the information in some locations where we have these samples, if we can get some information to also how to interpret the other drillings in an area, that would be a time and cost saving. So we have some really good people in machine learning here at NGI. Geotechnical Society in the world is organized in a large association, and this association had a lot of these technical groups. And the technical group for machine learning, the guy who's leading that group is sitting here at NGI in Oslo. So that's something that we really are working with and putting a lot of effort into to further development.
I understand. If are you using actually? Is there any result like from how you are using machine learning? Do you get like it is employed to generate a 3D model or something of the soil, or you just use it to find out about some patterns and after that you model yourself?
We kind of use it for the interpretation of the soil models. What happens between these points that we know the information of. So that's something that we use, but I think it's more used into the understanding of the soil and the strength parameters, deformation parameters, and so on. What can we expect? But yeah, we're using it for interpretation of some of the site investigations. So we use it for quite a lot so far.
Yeah. What about like we are talking about 3D modeling here? What tools, what softwares are you using to 3D model the soil?
Yeah, when it comes to the soil, we're using a software called Leapfrog, Leapfrog Works, which is actually software developed for the mining industry. I think it's in Australia. Of course, in addition to Leapfrog Works, we use some other software to handling the site investigation before, but that's where we're really doing the 3D modeling. And that's also where we managed to then communicate a little bit about this with the uncertainties. And that's quite simple way that we solve that. I think in our webinars, Per Anders talked about this a little bit in the first one, which is actually using different shadings of colors just to communicate to the other designers working on the project that, okay, this is an area that we have good information, and this is an area that we have less information. So here we have to be a little bit more careful about what we communicate.
I see. So there is no tool like, for example, like Civil 3D. It's not useful in this case. Cannot be used, or Revit or Tekla. This is not something suitable for this, right?
I think it's possible, but we haven't been using it. I think the advantage of using Leapfrog is that you have a software which is actually developed for this purpose. You don't have to build an interpretation model yourself. Historically, all Norwegian geotechnical companies, we use a program called Geosciences for handling the site investigations, and it's a Trimble program. Trimble also has of course NovaPoint, and in NovaPoint there has been this same interpretation function for the layering and so on, making a 3D model of the layering. But I think we found we haven't used NovaPoint for this for a while, but we found the functions in Leapfrog being really brilliant for this, and gives us very good and accurate models. So, and it's the strength is also it's very dynamic. So we can establish the model when we start, and then during the project we always get a lot of new information from site investigations, seismics, and so on, and then we can just add in the information and build on that model all the way. So it's really flexible and dynamic, and a brilliant tool for that.
I understand. What about interoperability and openBIM? How does this software comply with like, can you export in IFC or something? Like to combine?
Yeah, I think you can. I haven't been using Leapfrog so much myself, but I guess you can. I think you can export in what formats you want. I guess you can also follow the good old DVG file format, but yeah, I think you can also export in IFC if I remember right. But as I said, I haven't been using the program or software too much myself.
Understand. Okay, but getting back to deliveries, are there many projects right now that you are involved with or have been involved in the past, or that they are requiring a 3D model for geoscience?
Yeah, I think all or most of the large projects demands 3D models. NGI as a company want to work with complex and large projects. That's what we're good at, and that's what we want to work with. And of course, all these large projects, there are demand for 3D models. You can say that 3D models is something that we have produced for many, many years, but historically we used a lot of AutoCAD for modeling this, and AutoCAD is not very dynamic and very friendly for changes. And the problem for the geotechnical engineer is that we are dependent on the information from all the other designers. How did the architect want the building? Where did the constructional engineer want the columns? And then when everybody else has decided about the design, then we can make the design of what happens underground.
Yeah,
But at the same time, and the geotechnical engineer is the first one who has to deliver
exactly.
the models, because that's where the construction work starts, which then ends up you get a lot of you have a time challenge in many projects, because since we also then knew that okay, it's a lot of changes in the project, we have always tried to stall also wait with the 3D modeling, because we knew that okay, we can make a complete 3D model of this sheet pile, but we know that it's going to be changed several times before we finished, and that would cost the client a lot of money, and because it takes us a lot of time. But that's what we see now using newer tools, which is parametric modeling for these structural elements. So then we can early in the project establish a 3D model of the sheet pile wall, and every time the changes come in, then we can change it, and we can have these changes adapted really quickly. So I talked about we used Leapfrog for the soil layering, but we're using then Rhino Grasshopper for the structural elements. So like sheet pile walls, struts, wailers, beams, ground improvement, and so on. Then we are using Grasshopper for modeling this.
Okay, now I see. Yeah,
Yeah.
Grasshopper was it.
It's kind of two branches in the BIM way we're doing. We're doing Leapfrog for one of them, and then we're doing Grasshopper and Rhino for the other part.
I see. Interesting. Are the same people doing both of this, or there are people that are working mostly with parametric design and more people that work with Leapfrog? Or
No, it's a mix, I think. For some, they are mainly doing the modeling in Leapfrog. Some are mainly doing modeling in Rhino Grasshopper, and then there are also some who are doing a little bit of both. But in the end, they all are geotechnical engineers or environmental engineers. We're using also Leapfrog for environmental engineering, modeling contamination, subsurface. So everybody has the geotechnical or environmental or geologist background, but are working with modeling as a part of the design they're doing. So we're not having like pure people working with only design, except for one guy who's doing that. But mainly it's people also working with calculations and design in addition to the modeling.
I understand.
So it's a mix. We haven't. I think like in the future, we will probably have some people who are really deep into for example, the spaghetti design in Grasshopper, really knowing the spaghetti. But I think that a lot of more people have to understand how to use this model, because it's going to be a very important part of the daily work. So you can't rely on having to go and ask this guy, how are you going to, if I'm going to move the sheet pile wall 2 meters, how am I doing that? That's something that I think most people have to do. And then, of course, if you need a brand new Grasshopper model, then you get the help from somebody else to in-house to make that spaghetti.
Yeah. Yeah, well, I said, I mentioned this several times during this podcast. Knowing how to code, being graphical coding like Grasshopper or proper coding is going to become like to know how to know AutoCAD for 5 or 10 years ago, like a skill that everybody must have It's just like not only for construction. This is becoming like a very very important skill, because we come so often in contact with machines that we can make so much easier our life if with 2 lines of code or something.
Yeah, and I think like the newly employees we get these days, they are like 25 years old. They have 45 years of working in front of them. If you decide now that, nah, I'm not going to follow the digital development, then you're really going to be left behind within some years, I think. So I think I'm not saying that everybody should really dive into the deep coding and so on, but they have to have an understanding of what's happening and how this works. Because if you go like, take the other way, if you go 45 years back, then we're in the mid 70s. What happens from the mid 70s until today for the guys who are now going into the retirement? That's really a large change. And people really have to focus on, okay, I have to try to follow the digital development and understand what happens, because this is going to affect my daily work for the next 45 years. And then I can't just say that, no, I want to rely on using Word and Excel for the next 45 years.
Yeah, yeah. And here I think it's also something that must come like a change in the curricula of the universities. They must like everything starts there, right? So they must start taking this more seriously, like for civil engineers, let's say, right, or for geotechnical engineers. This needs to become part of what everybody is learning. Of course, you can learn on your own, but it's like we work in a way more advanced and modern way than 5 years ago, right? So it definitely must be done something from there.
Yeah, I fully agree. And I was like, when Norway closed down in March, we Enjoy saw that, okay, we can use this. This must be a period where it's a little bit less to do. How can we use this period in a good way? So what Enjoy did was that we set up an online training course that all the employees could sign up for if they wanted to. And that was a training course using how to program in Python or how to program in R. So that's a lot of people then signed up for it, and they can run some online internal courses, or it's not internal, we're using an external delivery also company
Platform.
on it. But, platform. But anyhow, it was a chance for people to learn Python. That's really brilliant, and I think I agree. The university should really have that as a part of. I'm not sure how what the IT courses on NTNU, the general courses, what they're teaching now, but they should really be programming should be a part of it, and not only programming but also understanding how programming works. Why is the structure like the way it is? Yeah.
Now, if you go back a little bit to your job right now, do you have an agenda with things you want to do, like to implement as a BIM strategist? Do you see some challenges that you must tackle quick?
Yeah, it's a lot to do. Now I should have just had the list ready for you and just hold it up. No, but I think this is more like a general challenge for the industry. But I think it's a little bit what we talked about as well. I think the early involvement of the geotechnical engineer has to be really good, and I think you showing what we can do with this parametric design, doing a dynamic model, always updating it, getting new information. Okay, this is the consequence for this. Communicating that to the project, I think, is a really something that we have to be better on. And then I think it's we have a challenge when it comes to the standardization and the attributes of the model. I heard you and Øyvind talked a little bit about this earlier as well, and that's something that's a challenge, because now we are establishing rules in each project, but we're not using it cross project. And of course, then the challenge is also for the other companies in the same project understanding the attributes and the I in BIM that we are establishing. So So I know that it's going on some work in Norway. For example, Bane is, I think it's now in November, they're delivering the second report on the KIM project, which I'm hopefully this would have some guidelines when it comes to this. But
It
at
has
least
been
I'm crossing my
published.
fingers for it.
It has been published last week.
The second one as well?
I'm not sure if
No,
it's
because
only one or two.
what I saw was that they published the first one, which is a general report. But when they, as I understand it, in the second report, they will say more about the information and the attribute flow in the project as well. And of course, Bane is a very important company when it comes to setting the demands for the contractors and for the designers. So that's really going to be interesting to see what they're saying. So and what we also see in some projects is the life cycle and obtaining data from the execution phase. We're delivering a 3D model, something to build after, but of course, as I said earlier, it's not everything that you see from what we are designing. Like a sheet pile wall, when it's installed, you see the top centimeters of the sheet pile wall, the bottom 20, 30 meters you don't see. So how is this actually done? And today we get a lot of information through PDF files and Excel sheets and so on. And I think that streamlining these information flows is something that we really have to work on. And that's something that we have to work on together with the contractors, so that we again can give them a correct as built model at the end.
Yes, you had some very good points there. As you said, Bane is doing a good job, a very good job actually. The people working on this new specifications for the new projects are very set to do a good job, and they are following ISO 19650, which is yeah, very important. And yeah, from this perspective as well, like I think it's important also for companies to see how they can implement organizational information requirement, for example, how they are going to use it on the projects when they are involved in and such. But it's good, like you said, things are happening, and the future looks really bright. And this period right now, the close up and everything, just sped up everything.
Yeah, that's a interesting thing in also digitalization in general has had very good effect on the corona situation, because in February this year, I don't think anybody should thought that we can work the way we're now working. So the COVID situation really speed the digitalization up on a lot of ways.
Yeah, that's true. By the way, what's your opinion about digitalization generally and BIM adoption in Norway?
I think it's quite good. I think we're Norwegians in general are very pro when it comes to everything that is digital. You can see it's just in the daily work how we do using technology. I think we're very far, very in front in compared to very many other countries. And I think it's kind of the advantage when it comes to Norway and digital development is that we have rather flat hierarchic structure in the society, so that like in many countries, it's like, okay, the old guy on top, he decides, and then everybody beneath him has to just listen to him. In general, of course there are exceptions, but in general, the old guys in the 60s are not the ones doing the digital transformation. So you really have to rely on the young guys and girls in the 20s and 30s who's really pushing the development. And I think that's really an advantage in Norway, that like here at NGI, it's no problem, or in any company in Norway, it's not problem to go and talk to the boss or the boss of the boss or the boss of the boss of the boss and say that, okay, we really have to do better when it comes to this. And to talk about NGI, we have really pushed digitalization for the last couple of years, and I know working quite with a large digitalization project, which the BIM transformation is just a small part of it, but it's a lot when it comes to data storage and how to have optimized working processes and so on within the organization. Of course, we talked about machine learning a little bit. I think our archive is a gold mine when it comes to potential for machine learning. But of course, a lot of the archive is old PDFs and so on. So we have to prepare to, okay, how can we get the data out of all these old reports and files so that we can process them and use them in machine learning. And that's really a part of this digitalization project that we are doing here at NGI.
Yeah, that data needs to be digitized, and the maybe a challenge with that is not only that it's a very long process and very slow. You cannot just throw on the scanner all the documents at once, right? It's not only that, but maybe exactly that is not getting you any money, because it's something you need to do. You have it, you did it already. You don't get paid maybe for that, so it's a challenge for companies to do that. But nonetheless, I'm quite sure, like you said, that data can be a treasure to harvest it, and you can definitely learn a lot from that, especially for geosciences.
Yeah, and you could say like for us for the last 20-30 years we have most of the files, as the basics for the files are digital because they're lying on one server, so it's possible to find again. But if you go pre 1990 1995, then everything is all reports typed on a typing machine. So but of course, transforming those into PDF, I don't think it would take a very long time before we can also just read all the data out of it and get it into the database. So, and then again, then I have all, NGI was established in 1953. So of course, if you can have all the data from all the projects that we've done for those years gathered in the database, it's a fantastic source for machine learning.
Yeah, and if you are aware about this, I'm sure then it's going to happen something with this in the next years then.
Yeah.
How do you see? I don't see too much. Like you said, because most people require you only when problems happening. But how it's your relationship with the general contractor and the designer generally, and the owner or the client? Do you have the same, like, is the same differences, like for example between designer and contractor? Like there used to be, like there are some, always there is something that doesn't go so nice along with between engineers and architects, for example, or something, right? How are you? I don't hear too much about from your part, from geotechnical aspect.
So NGI is a pure geoscience company. So we only working with geosciences. But if you go to like large consultancies like Norconsult or Sweco or Multiconsult and Rømoen and so on, then the geotechnical design is one section in those companies. So then for them, they deliver all different designs: the structural design, geotechnical design, water design, and everything. So, but in general, we have like the same connection to the clients like everybody else. As I said, we're working on a project in Drammen now for Veidekke, and there we are designing everything that has to do with geotechnics. Another company is doing the entire design when it comes to structural. The third company is doing the design when it comes to the alignment of the tunnel and so on. So I think it's the same like everybody else when it comes to this. But it varies, of course, who we're working for. So sometimes we're working for the contractor. Sometimes we're working for another consultant who need geotechnical expertise, and sometimes we work for like Bane NOR or Statens vegvesen in these projects. So it varies a little bit who's our client in these projects.
Yeah, I understand. What trends do you see in our industry that you are excited about?
I think it's like, especially maybe in infrastructure projects, it's like a colleague of mine said, he explained it, it's almost like Klondike, that people are really expecting gold at first when they're implementing BIM in the project. It's like everything is solved, but we maybe see that it's not that easy to get a good flow, as I'm already explained a little bit as well. For us, it's been really easy to make that, not really easy, but it's making the 3D models. It's something that we really handle well now, but we still have to adapt to a workflow in these projects. And as I said, we are normally working for a contractor or other consultancy, and when it comes to then the collaboration part and what kind of software we're using in this collaboration part, and we just get told what to use in this. So we have to adapt them in what kind of software we're using. Otherwise, I think it's really cool to see what some companies have managed to do running projects without drawings. I mentioned Øystein Ulvestad's before, and I'm really impressed about what they did on the Rømoen Bridge. And that's also something that has inspired us, what they did there. Within Geosciences, it's also something that we're starting to look into is the data collection and real-time monitoring and how to link this into the model. Of course, we're doing, like, for a large excavation pit, we're doing a lot of monitoring. How can this be linked into the presentation of the, as like kind of like a digital twin, which also gives you information about what happens with the forces in a given strut during construction. We have the calculation, what happens, what do we measure, how can we get everything this into a model, which also can give you then a chance to optimize the design during the project because of the observational method. So that's really cool. Yeah, and I think, as I mentioned, I think the chances for us to do dynamic 3D modeling early in the projects, that's really something that's going to gain the industry, because it's I think we will manage to show the consequences of our work in a much better way that we managed to do earlier. That, okay, you can decide to lower the road 5 meters, but based on that, this will happen to the model, and the cost that you get is 4 times what you had before for this small structural part. And I think that's something that we really need to communicate even better than we have done before.
Yeah, that's like having the possibility to iterate with different solutions and give to the client more options to choose from. They can choose if they want a more robust solution, a more costly one, right, or a cheaper one, but to know the consequences if they do that and what they lose. Yeah, that's really nice. What about the AR, VR, mixed reality? Did you see any application for you here? It's is something that can be applied for you?
Yeah, when as I said, we tried a little bit with AR. To be honest, we haven't used it too much. We played around a little bit with sight vision, for example. Some of the challenges that our structure is underground and not visible. When you see these demonstration videos for like sight vision, then you see how you can see the structural sticking up from the ground and how it's going to be with the finished bridge when you're sliding over and the vision. And that's not maybe so easy always to see here, but I know that Øyvind at Svaland at the Drammen project, they used it, for example, for controlling the location of, also, they were marking on the ground where to put the sheet pile wall, and then also took out the sight vision afterwards to just compare it to the model and see that, okay, we are actually in alignment with the design and so on. So, of course, and I think when we're starting to excavate the excavation pits and so on, of course, it's a brilliant way to control that. Okay, this is the sign is in alignment with what now the construction is in alignment with what we have designed, and this strut is located on the right level, and everything seems really good. And there I also think that combining scanning and photogrammetry into the daily work or daily follow-up of the projects should be really nice. geotechnical engineers are pretty picky when it comes to the slopes that they're excavating on large sites. They can't be too steep, while the contractor very often wants them almost vertically. And of course, if you have a drone flying over the entire site every day, scanning the terrain, running this check against the excavation plan for the entire site, or just measuring the inclination of the slopes, then you have a very easy, quick, and cheap way to control how the excavation is done on site. So yeah.
Yeah, interesting. What about virtual reality?
We haven't we haven't used it too much so far. We played around a little bit with it, and then we'll just see how this ends up. I think definitely is going to be for some use, but I'm not sure about how now. But of course, yeah, we'll see how we manage to use it in the future. I think the potential is definitely there, and then we just have to try it. And then if we find out that this didn't work out anyhow, then we just skip it. But I think the potential of those new tools are really there. If you go 5 years back, we didn't know what we were going to do today. So what happens with the technology development and so on, we'll really see in the upcoming years.
Yeah, really exciting times we live in.
It is.
For better and for worse. Yes.
Yeah.
We don't know how long we are going to be locked down. So this is also another aspect. Like we are forced to just find more effective ways of working, right? And cooperating. What advice would you give to a geotechnical engineer or someone working in geosciences but doesn't work with BIM? What advice would you give them if they would like to work more in the future with BIM? What should they do?
I think the important point is interest, motivation, and passion. But based on what you're saying, that's something that they already have. For us, it's we had if I'd like to say the development on BIM at NGI for the last 1.5 years. Also before that, we still did 3D modeling, but I'm not sure if I would call that BIM because the information part was quite was not that good. So what happened for us was that, okay, we have our good friends in GeoVita, which is a Norwegian consultancy company, which we are doing our webinars together with. And they really inspired us on what they have been doing when it comes to using both Leapfrog and also Grasshopper. And then after that, we got the understanding from both our managing director, Lars Andresen, and also the market area director, Guru Grønning, for using hours and costs and money on this, this was something that we really have to do. And I think that's something that you also talked with Øyvind Svaland about, getting support from upper management. That's really important, because otherwise it's really going to be it's difficult as it is. You don't need the fight internally in addition. So that's really having the support and backing from the leaders. That's really important. Then of course you need skilled and good employees, which sees the potential and advantage and which are curious. That has been no problem here. It's a large group of people that we started with a few people, and then it has been growing over the time. So that's also important. And what we also, as I said, we have a large digitalization project here at NGI, and as a part of that, we have hired some external developers and also project management. And one of these guys, Olav Pazina, he has been running the BIM development for the first year. So I kind of took over his role, and having a combination of our geotechnical background and his IT background in finding out how we're going to structure the BIM at NGI, that has been really good. So Olav has made a brilliant job when it comes to this. And I also must say that you had Øystein Ulvestad as a guest earlier. What he and Krzysztof Wojslaw has presented, that has been really inspiring for us. And I think to watch and follow webinars, that's really a good tip. The amount of webinars has kind of exploded the last 7-8 months. When everybody's sitting at home, everybody thinks that they has to have a webinar, us included. But there are a lot of webinars that are not that good, but there are also some webinars that is really, really brilliant. And so you just have to see through those that's not that good and see those that really brilliant. So that's also a very good tip to how to start this, because it's a lot of information. And then also just YouTube and forums. I think some of the guys and girls here at NGI has used quite a lot of time on YouTube and forums to understand how this works and learn even more.
Yeah, there are many resources. There start to be more and more resources out there. So yeah, it's good to use.
And what's cool is that a lot of people are really open about what they're doing. They want to share, and that's of course the key. And I think that's also been some of the inspiration for the webinars that we are running. Okay, we could have been sitting here and hiding everything that we know and everything that we learned, but felt that okay, this is something that we have to share, both to manage to push the geotechnical or the geosciences forward. If we can help doing that, that's brilliant. But also it's in our interest to tell our clients that okay, this is what we actually managed to do, or potential new clients, this is actually what we managed to do. So sharing is important both for your own and for everybody else's sake, I think.
Exactly, and is the only way that we can speed up the improvement of our industry. Like we need to open ourselves and work together. And like you said, that will work as a portfolio for you anyway. It just is going to be a bonus. So you said you had some webinars, BIM for Geosciences, right?
Yeah.
They can be found on YouTube, right?
Yeah, we have had 3 webinars so far. They are available on NGI's YouTube channel, and then we're planning on the 4th webinar in December or January. I think we'll see when we end up having the next one. So that's so far the feedback is pretty good. So and that's nice. That's nice to share what we learn and what we have learned for the last years.
Yeah, very good. Keep doing that. It's important.
Thank you.
How can somebody contact you if would be interesting to ask you about something?
I'm on LinkedIn, so I guess my name will be in the title of the podcast, so
Sure.
there you can find it. Or my email is mar@ngi.no, so that's quite easy. So feel free to use email or LinkedIn.
Sure. Well, Magnus, thank you very much for introducing me to Geosciences.
Thank you very much for having me, and thank you for a nice podcast. I've been listening to it for the last couple of weeks after you invited me, and it's really nice. So keep up the good work, you too.
It's so nice to hear. Thank you very much. I'll do that.